Oh, sorry, I think I lost my connection there. Can everyone see my screen?
Yes, we can see your RStudio and your background. Yeah.
Excellent. Okay, great. Is it big enough is the next question. Should I try to make it bigger?
Probably bigger will be great. Yeah, that's great. Thank you.
Great. All right. So the first thing you're going to want to do, as per usual, is just make a new R script if you haven't already. So File, New File, R script, or there's a shortcut if you're especially advanced. And I always just make this and save it somewhere quick. If you've got a project from the project tutorial, you can save it there. I'm just going to save it in my downloads for now. This will be data frames. Something like that. And just get that file saved. Just move this to the side. All right, so if you remember from last time, Natalia was talking a bit about the different kind of types of objects and things out there. So, and specifically different kind of like classes. So like, remember numerics, character strings, factors, things like that. And then I think at the end, it got to a bit of data frames. So a data frame is just a collection of kind of different vectors of data. So remember, a vector is kind of like a column of data. Data frame is you stick all those columns together, and it can have different things in it. It can have like character strings in one column, it can have numbers in the next one, and so forth from there. So it's the most useful object, obviously, for, well, in my opinion, for data manipulation, but some may argue against me. So we'll first just practice adding columns and rows to a data frame. So I strongly, if you're new to R, you're learning R, I strongly recommend you try and follow along and just write some code. It'll really help if you're actually putting lines out there and practicing this. So we'll just make So we're gonna make columns and rows of some vector called age, and I think it's gonna be cat ages. So it's gonna have values 2, 3, and 5 for 3 different cats. So each cat by row will have age 2 cat, age 3 cat, age 5, and we can highlight this and run it, and it'll be, if nothing happens, that's a good sign. That means it went into the object. And again, if you want to see what's inside the object, we just write age by itself, and you can run that, and you'll see what's inside the object you just made. So hopefully this is all pretty boring so far, because now we're going to go into kind of newer things. Oh, and I think that we've already at this point in the tutorial, we've also made a few other things. We've already made a data frame called cats, so I'll just make that quick. I think it's from a previous one. So we're going to make a data frame called cats. The way we can make a data frame is we just write data.frame, and then we're going to define each column of this as a vector. So the first one will be the coat color of the cat. It'll be a vector like that, and we won't fill it in just yet. But we can put a comma, and then on another line we can make the next column weight, something like that. And then finally we'll have another column that's just likes string. This is all from, I think, last time we were doing this. We had columns like this, and the values for this are going to be calico, which we put in quotation marks, black, and tabby. Oops. Weight will be 2.1, 5.0, and 3.2. And like string is 1, 0, 1. Now, if you're trying to write this all at once, I'll just paste this in the chat, and it will work, except for you'll have to replace the quotation marks when you paste it in. It might not work with the quotation marks. So you can try using that code if you don't want to write this up yourself. Maybe someone can try copying what I've pasted in the chat and just see if that's actually going in properly. But at the end, we should be able to print cats, and it should print out something in the bottom like this, where it's got the coat in one column, the weight in the next column, and likes string in the final column. And this is just a basic data frame. So remember that in the first column, we've got character strings. So in quotations, that's a character, different character strings. So this is like one character string. And then when we attach multiple together, that's called a vector. That's what we use the C command for. That's like a column, one column of data is a vector. And then finally, that column has a name, we call it coat, and we save it into a whole with other columns in what's called a data frame. So the whole data frame is going to be, we're going to assign it to a value called cats. So so again, just from the inside out, it's kind of confusing. There's many different things going on, but in the data frame, we have 3 columns. The first one is coat. It's got a bunch of character values. Weight is going to have a bunch of numbers or numerics, and like string is going to have these integer values, so just zeros or ones of whether the cat likes string or not. Oh, thanks, Natalia. So then when we run all this together, we should get out something like this. Now we're good to go. So that's our initial data frame that we're going to be working with. So the first thing we want to try and do is we want to add some new columns and rows to this data frame. So we're just going to try and add a few things. We can try a command called cbind. This stands for column bind. This is where we're attaching columns together. And so we can attach on, with cats, we can attach on the age column by doing this. So we go cbinds the cats data frame with the age vector. We'll get out a new data frame that has an extra column now. So we've added a whole new column of data that way. So that's a really easy way to add a column to it. I can't see my screen. So, so note that if we just tried to add a different age kind of vector that has more ages than we have cats, like we go age and we do 2, 3, 5, and 7. So now we have 4 different values of age. We can run this, and I run it by hitting Command Enter on Mac to do the shortcut. You can also just go run at the top. Now when we try and cbind it together, cbind cats with the age vector, can anyone guess what's going to happen? It's going to be a problem with it. So it's saying error in the data frame. The arguments imply a different number of rows, 3, 4. Does anyone know where that 3, 4 comes from? Or has a guess to where it's coming from? No one wants to put on their mic.
The coordinates, is it? I mean, I don't know, I'm guessing.
No, that's a good guess. Yeah, so it's all about the 3 values in the, so as Tom was saying, yeah, it's, and G was saying, it was, it's basically about the length or the number of rows in each of the things we're trying to combine. So remember, here we've got this data frame, and again, if we just print it out, if we just run cats by itself, we've got this data frame that basically has got 3 rows, and then we're trying to combine it with this age. That if we just put age by itself and then we can print it by itself, we see it's got kind of 4 values. So we're trying to merge something that has 3 rows with something that a vector that has essentially 4 rows. So we can't, R doesn't know what to do when you put this 3 and 4 together. So it gives an error when you try and combine them. It's got this cbind, and then it's like, I don't know what you're doing. why are you trying to do this? So it gives us an error just because it's not matching the number of rows. If you can kind of imagine it that way. So again, just to recap, the cats has kind of 3 rows, and age, when we're trying to merge it as a column, it's essentially got 4 rows, 4 values to it. So it doesn't know what the 4th value is. It's confused, so it can't merge the 4th value. Whereas up here, when we had it before, age only had 3 values, so we're able to combine 3 and 3 together. But if it's got a different number of values, it's going to give you an error message basically. And this error message is helpful because it gives us this 3 and 4. It tells us exactly how many rows are in each one. So we can figure out which one is incorrect, I guess, just by looking at this 3 and 4. Does that sort of make sense? It's a weird quirk, but it's a really common error that I get all the time, at least. And it's really important to be able to solve it. Another thing that can happen, so if I just copy this code and I'll paste it down here just to save a bit of space. Let's say it's let's say I delete the first 2 values. So now it's just 5 and 7. So you can see age, it's just 5 and 7. Now again, if we try and cbind or column bind these 2, it's again going to give us another error message. It's saying, what's going on? You've got one with 3 and one with 2 now. And again, you can't combine different numbers of rows together in a cbind at least. So that's kind of what's going on with that. And yeah, I think the 3 people in the chat, yeah, exactly. You're right on the money with your answers. So if we want to tell if we don't want to get an error message, we just want to figure out how many rows something has, we can run the n row, the number of rows function. So we can go number of rows on cats. It's got 3 rows, and we can do number of rows or number of row on age, but I don't think this will work. So the weird thing about number of row on age is that it doesn't work. It'll give a null, and it's not because it doesn't have any rows. It's because n row only works on data frames, and it doesn't work on vectors of data. So again, if you look at, for instance, type of, which is a command from last tutorial, I believe this should work. Oops, types of. I can't remember the command from last time. But another one you can use is just is. That's one I usually use. So if we run is on cats, it'll tell us right away the first thing it is it's a data frame. And then if we do the same thing on age, it's a vector is one of the things it is, but it's not a data frame. So are you gonna say something? Oh, I just realized we're not recording right now as well. Or are we recording? Okay, cool. Maybe we are. Okay, we are recording. Great.
Yes, we are.
Thank you.
Yes, we are. I pressed recording. Sorry, should have said.
So the way we're gonna get the basically the length of age is because remember it's just one column. So the way we're gonna get the number of rows kind of in that column is we have to use a different command. We have to use length of age, and this will give us 2. And that's just because age is a vector, whereas cats is a data frame. So if I were just to rearrange this a little bit, I'd put this down here maybe and show you the 2 commands side by side. So we could run length on cats, and it actually it knows what it's doing when it comes to length on cats, but it just the number of rows won't work on a vector. So we have to use length instead. So that's one really kind of a trick to it is when you're using a vector, you got to use length instead of number of rows. Whereas with the data frame, it's probably better to use number of rows. And we also have another one, I think that we might get to in a bit, that's just called, we can also use number of columns, ncol, and that should give us the number of columns as well, which is also 3 in this case, if we look at what's in cats. So this is number of columns, type of, thank you. I thought it had an underscore in it. Rows. And then so another one we can use just to add even more functions to this, which is the one I was trying to remember. I was putting an underscore in, but it's just by itself type of cats. And it's a type list technically, because data frame is a type of list. Technically, if we're thinking of the base structure of it, whereas age is type of age, it's type double, and that's because it's a vector type. So double means that we've got it's a number with possible decimal place after it. All right. So again, for things to work, we need the number of rows. We need the number of rows to equal of cats to be equal to the length of age. Oops, of age. So we need these 2 to be equal in this case. And if we run this, this will give us a true or false. And so right now it's a false for whether or not they're equal. But we need them to be equal if we're going to be able to use cbind together. So again, if we just run parts of this, so we can highlight just parts of it and run that, we can see the number of rows of cats is 3. And the current length of our age object is just 2. So it won't work. We won't be able to combine them together unless they're both the same number of rows into a data frame in this case. All right. So that was adding columns, but what if we want to add a row to our data frame? So columns are a little bit easier because one column is all the same amount of data, right? The same kind of data. If we go look back at our cats, we've got one column is just, it's all character string, or it's all a number of weights, or it's a integer of whether or not the cat likes string. So it's easy to add another column that has all the same data in it. The tricky part is now going to be when we add a row, we have to be very sneaky kind of with it. So now if we're adding a row, if you can imagine, we need a coat color, we need a weight, and we need a like string. and they're all different types of objects. So it's going to be a little bit trickier when we try and add a row now. So we basically need a list of different object types. Oh, and sorry, before we move on, we're just going to add one thing up here. We're going to add an age column to this. So let's go back to I'm just going to copy code from the top, this age column. I'll just paste it down here. So we'll remake age as 3 values. So now if we look at the length of age, it's got 3 values. The number of rows of cats has 3 values. And now we're going to assign a new value to cats. So maybe let's call this, just to keep it a little bit more simple, let's call this cats2, just because we're remaking an object, just to keep track of it. So we'll call this cats2. We're going to go cbind, just like we did above, cats and age. The difference is now that instead of just writing this by itself, we're saving it in an object. So we're saving it as cats2 now. So if you try and run this, you can run these two together. If nothing happens, that's a good thing again. So if nothing comes in your console, that means it worked correctly. If you see an error message, it's probably because one of these two doesn't have the right number of rows. So you can just check to see the number of rows and the length of the age, and just make sure that they're the same number. And then hopefully it can combine. Oh, it's cool that n row in caps would work as well. I'll try that. Oh, so there's this capitalized n row function that Gia's found that we can also use capitalized n row, and it seems to work instead of length of age as well. So there's another function you can use for that. So it's up to you which function you pick, but all right. So has everyone been able to get this cats2 to work? So you should now be able to print out cats2, and it should return 3 columns and 3 rows and 4 columns in your inner data frame. Can everyone get cats2 to work? If so, just give a thumbs up or say something in chat if it's working for you. If not, oh, awesome. So far, good. If not, we can pause for a second and get it working. It's just because this tutorial is going to keep building on this, so we got to kind of keep things working from the previously for it to keep working. So if not, give a holler. We can probably just put in the code for cats2, how to make cats2. Someone can throw it in if we need it, if it's not working, but do let us know. No shame in it. I constantly get screwed up by this kind of stuff. So, all right, so now we're going to try to add a row to our data frame. And I'm already pretty slow on time, so I'm just going to do this slightly faster. So we're going to go new row. We're going to assign this new row object a list of values. So remember that the row is going to have multiple different kinds of values. We're going to have, for instance, a list of different values now. So we're going to put in tortoise shell as the color of a cat, which I didn't know that was a color, but that's for the coat color. We're going to put in the first value is coat color. Second value is going to be the weight. So the weight of this new cat coming into our data set is 3.3. Whether it likes string, that's going to be a value of 1 or 0, but we can actually also use true or false for this. So true in this case represents a 1. And we can put in a value of 9 as the age. So this cat is a lot older than the other cats coming in. So this is kind of like our new row or new cat coming in. And if we run this, again, it should just evaluate and nothing should happen. But we can check to see that there's something in there if we just run it by itself, new row by itself. We should see this weird output this is a list kind of output, so it looks a bit odd, but don't worry too much about how it's output. It should be working now. So now we can make a new value of cats. Let's call this cats3. We're going to assign it a value using, instead of cbind, which combines columns, we're going to use rbind, which combines rows together, if you can imagine that. So rbind combines rows, or it stands for row bind, and we're going to put in cats and our new row of data. And assuming that, again, remember that the new row is going to have the same number of columns as the previous data frame cats. They have to have the same number of columns now instead of to combine them properly. So we can just, before we run this, we can just check it just by running. Oh, sorry. And this is cats2, my mistake. Cats2 is our new one that we're working with. So we're going to row bind cats2. And so if we just run this, it should work. I think if I had cats by itself, it wouldn't work. Oh, it did work actually. It's wow, it's amazing that it does work even without it. It just drops one of the values. It drops that age column. So it does actually work if you just use the original one. But here we're trying to keep that fourth column. And now we should have 4 columns and 4 rows in there. All right. So it should be good to go. Has everyone been able to get cats 3 working now? Great. Awesome. All right, so the next thing we're gonna be working on is something called factors. So factors are just a way of coding character strings a little bit different. So for instance, if we run levels, levels is the way you can extract whether or not something is a factor. So if we just run levels on cats, and we can refer to the specific coat color column by running $coat. So just this part alone gives us just the different coat colors. Oh, and sorry, it should be cats 3 again. Cats 3 coat. If we run levels on this, it just doesn't do anything. And that's because right now it's just a character string. It's just a vector of character strings. It doesn't have a factor kind of designation yet. So we can make it have a factor designation in a number of ways, but one way we can do it is by writing into this, we can make a vector. I don't think this is going to work the way they have it. I'm just going to show you a different way of doing it. One way we can reassign this as a vector is we can write cats 3 $coat, and we can assign it as a factor just by writing factor and then writing in again cats 3 $coat. So when we run this, again, nothing should happen. That means it went into itself properly. But if we just print it out now, if we just look at that one column, we can see now that there's this new thing at the bottom. It's got this levels designation. So a factor is a way of just defining, different categories. So if you know that something's going to be a categorical variable, if you know it's going to be like A, B, C, D, and you can't add them together, you can assign it as a factor. So this is a good way of, in your kind of data analysis, it's a good way of telling something's a factor. And it's really important, especially if you've got your groups coded as like 1, 2, 3, 4, because R will just initially assume that your groups 1, 2, 3, 4, you can add them up as if like, group 1 plus group 2 equals group 3. But if they're different groups, like maybe it's like different subsets of people, you can't add together groups. It doesn't really make sense. So in that case, you really have to assign them as a factor to make sure that R knows what it's doing. So here we're just assigning the coat column as a factor. So once it's a factor, it's a little bit tricky to get rid of. So we can now look at this. If we just go is and we put in this column specifically, we can see it's a factor is the main thing that comes up. Another way we can look at this is we can write structure cats 3, and it will give us an idea of what all the structure in the whole data frame looks like. So we got coats is a factor, weight is a numeric, like string is numeric, and age is a number as well. So they're all numerics, the other 3. But like string actually, whether or not a cat likes string, we can't add whether a cat likes string plus a cat that doesn't like string does not equal a cat that likes string. It doesn't, 1 plus 0 does not equal 1 in this case. It's like kind of true or false. So it's actually a little bit different than this. So we should also probably change like string to a factor eventually as well. So it should be more like, we could do the same thing if we wanted to with like string. We just copy this code above. And here's where I'm probably going to screw up things in this tutorial. But I'm deviating a bit from the roadmap. But like string, we can change here as well, like string. And if we run this now, we'll now basically factorize this whether or not like string. And now when we look at the structure, we can see that we've got 2 factors. Coat and like string are both factors now. So now it's not treating that 1 or 0 as a numeric. It's actually being like, okay, 1 is like it likes string, and 0 is it doesn't like string. The cat doesn't like string. All right. All right. So now is our first challenge question. And so this will be a good opportunity for you to try it out. So I want you to try and create a vector called human age by multiplying cats by 7, essentially. So in theory, cat's age is roughly equivalent to, or so human age is roughly equivalent to a cat's age times 7. So cats are 7 times less, or age 7 times faster than we do. So step 1 is going to be just creating that factor, creating a vector called human age just by itself, by multiplying the cat's age by 7. Step 2 in that, we're going to try and convert human age, that human age to a factor. And I haven't showed you step 3 is, this is a real challenge, but I haven't actually showed you how to do this yet. So we'll go over it. Don't worry if you can't get this third one, but try and convert human age back to a numeric vector using the as numeric function. And then I think we'll leave it at that, and then we'll just discuss your results. So does everyone want to try and do this quick? So think about step 1. How would we convert human age, or so how would we make this vector called human age by using this cat's $ age column? How's everyone going with that? More time or less time for step 1? Any ideas? Or any input on how people are going? Anyone done step 1, or even all the steps? So the first thing I'd start out with is just to create a vector, we're going to put in this arrow thing. Oh, you're doing the fancy way, bro. Get out of here, tidyverse. That's for later. We're not there yet. that is one way you could do it. So Bruno's posted a way using tidyverse. You'd have to load a package called tidyverse first for it to work, or specifically dplyr or magrittr to use it first. Yeah, so one way we could do that is just to do so Cesar's done it. So in the actual column of the data frame, we could create it. I was more thinking just in terms of just creating just one object by itself called human age. So it would be this kind of the same thing. If we wanted to use the cat's $age, we can extract it just by writing cat's $age. Oh, did I delete it somehow? Sorry, I might have deleted this while. Oh, sorry, cat's $age. Keep forgetting yeah, thank you. Cat's 3, because we keep changing the data frame. Cat's $age, and then all we'd have to do is just add that times 7 as Cesar's done. And if we just look on the right-hand side, just to make sure it's working, we get 14, 21, 35, and 63 are human age for each of the cats. And then finally, we can save it back in as human age. And now when we print it out, human age should be good. What about converting it to a factor now? So we got the human age as a vector. Maybe we want to create a factor of this. So one thing we could do is we could just write factor human age, something like this. and we haven't saved it as itself yet. So in doing this, I've just kind of printed it out. But if I want to actually save it in itself, I have to, again, right at the start, I need to just write human age. I'm going to save it over top of itself. So I'm kind of factorizing the human age and then saving it into itself again is what this code is doing. So it's factoring it and then it's saving it as itself. And when we run this, then again, we can look at human age. And we get a number of different levels as well. Now, here's the tricky one. Now we've got these different levels. Now let's try and convert them back to a numeric vector. So we can write as numeric human age. And we get something very odd happening. We get 1, 2, 3, 4. So what do you guys think is going on here? Why are we getting 1, 2, 3, 4 when before we had, we had values like 14, 21, 35, and 63. But when we try and convert it back to a number, it gives us 1, 2, 3, 4. Any idea what's going on? This is a really big, this is a huge kind of issue that people always tend to run into. If you're trying to convert it back to the original number that it once was, there's a kind of a sneaky way you got to do it, unfortunately. So what's happening with R is just that it thinks that for some reason, once you put it into a factor, it's basically assigning these different factors kind of like A, B, C, D, and they have no denomination now. They don't have any number associated with them. So it's kind of like rank them essentially. It's just put them in A, B, C, D. Now, the next thing when you put it into as numeric, it's basically telling R, okay, I want you to take the A, B, C, D, convert it back to a number for me. So the only way R knows how to do this immediately off the bat is just to assign A value of 1, B is a value of 2, C is a value of 3, and D is a value of 4. And so it's just going to go up 1, 2, 3, 4, 5, 6 if you have more factor levels. So R gets really confused by this. And it's just going to spit out 1, 2, 3, 4, however many like kind of factor levels you have for each factor level with this. So this doesn't work. This won't. Yeah, so it's a huge issue that scientists do all the time. So it's really important to be aware of. You can't use as numeric immediately to convert it. So what you have to do instead is we have to go back to a different way of getting back to a numeric. We have to convert it to a character string again. So we can convert it back to a character. Then we can convert it. Then we can convert it back to a number. So we can basically do this by writing the same as numeric as above. I'll just copy this down here. Or sorry, I'll write as character. You can see when I do this, it spits out 14, 21, 35, and 63 in quotations. And then we can write as numeric. And inside of this, we can just paste what's up here, basically. So we'll go, first we're doing as character, and then we're going to run as numeric on top of that. And what we then get is we finally get our numbers back from that. And if we wanted to resave it into the human age thing, we could write human age, and then like an arrow into it to save this part in. And now finally, if you look at it, if you just look at human age by itself, we've got the right numbers, and we can even divide this by 7 to get back to our original cat's ages, 2, 3, 5, and 9. All right. Does that sort of make sense? It's a weird way we have to go about converting it back from a factor to a number if we have to do that. So if you're saving something as a factor, it's always best to be certain that you're not going to need it as a character string. So I recommend just saving a different factor. Like if you're going to convert, for instance, human age to a factor up here, we could just call this human age 2, or a new column called human age 2 or something like that, or human age _ factor or something like that. It can really help to save you time when these kind of problems emerge. Does anyone have any questions about that kind of thing? I'm debating, because we've got a lot to go through with the other one, I'm debating how much we can go through the other one. So we might just, the rest of this stuff, it seems a lot to be with data subsetting anyway. So I might move on to the data subsetting part, because this is the kind of the real important messages of data frames. It did not work for you. Which part? I know why. No, I don't know why, but maybe the error message can help. What if you just print human age by itself? Are you getting out, or maybe try writing just I'll write it down here.
Hi, it just didn't. So I did everything, and at the end, when I say as numeric as character, it has still the 1, 2, 3, 4. So it didn't convert it back to the values, the original values.
Oh, okay. Maybe it's because try just you might have saved it as human age. If you went human age and saved it as numeric, that would now convert it to completely to 1, 2, 3, 4, 5, or 1, 2, 3, 4. So try just repeating step 1, then
Yes.
step 2, and then kind of skip this one's, the step 3 won't work. So just skip the step 3 and then try doing this one next, and that might help. You want to share your screen, or?
Okay. I can't.
Oh, it's
Host disabled participant screen sharing.
you might have an option off. Yeah.
Well, maybe I just copy the.
Yeah, just try creating a new vector, like again, like this.
Okay. Yeah, do that, and then
try running this as a factor.
Mm-hmm.
And then next we skip down here and do this. Try this long one.
I didn't save it. I don't know if that's.
Oh, okay.
Okay, and then... Okay, it did work. I didn't save it.
Okay.
Okay, was the issue. Thank you. Sorry.
No, I'm glad. Yeah, please feel free to interrupt if it's not working. It's better to figure these things out. And I'm sure like people never speak up, but everyone's got the same kind of problems arising because I'm not being clear. So thank you for being brave and sharing the issue. So let's talk about subsetting now. I think we've gone through the majority of stuff in data frames that's really important, and we're running out of time. So we'll just jump to this subsetting page. Oh, and also I'll post this link. There's a pretty funny, oh, where's my chat? Sorry. There's a pretty funny link if you're bored about the actual human cat's age. There's a little scale bar on this one website that you can go to where you can actually look at the true cat's age. And if you're really bored, you can make a challenge you to try and make a function of true cat's age in terms of this chart. So for instance, when a cat's 19 years old, they're about 92 years old in human years. But anyway, so we're gonna go into the subsetting example now. I'll paste this one in the chat as well. And I'll just kind of play around with this. So one thing that we could have done with our old cats data, if we still have it open, we can subset it. And the way you subset things depends on if it's a vector or if it's a data frame. So if subsetting a vector, we can simply do something like, for instance, with our human age vector that we have, we can just open square brackets. And this is that square brackets represent like when you're subsetting something by numbers. And we can just put in a value of like 2. And what this does is this 2 represents the index, the subsetting index you'll hear a lot. And that just means that it's going to take the second value only of this vector of human age. So if we run this, it'll just give me back the second value, which is the value 21 in this case for human age, which I have saved. So this gets back the second value of human age. second value in the human age object, which in this case, it should be a value of 21 years. Similarly, we can also use things like minus signs. We can go human age -2, and we'll actually get the opposite. We'll get everything except for the second value. So this gets back everything except the second value. So it's quite interesting. You can really, you can imagine if you're trying to pick certain values out, it becomes really helpful. But again, this is just for a vector. So remember, a vector is just kind of like a single column of data. We have to use length instead of n row to get the number of kind of entries in there. So what if we have something more complicated? Like what if we have a data frame, for instance, which is usually the thing that you're trying to subset, and it gets confusing. And you can also use things like, as Cesar was saying, you can use like human age, and we can put in something like this. This gives us the values from 1 to 3. So if we just printed, for instance, what's 1:3, that gives us values 1, 2, 3, which then means that it's going to give us everything except for the fourth value. It's giving us, gets back the first, second, and third values. So there's many different kind of ways of subsetting with these indices. So with a vector, it's just one column of data. So it's easy to be like, this is the first value, second value, third value. But if you imagine in a data frame, we've got this kind of like a matrix now of data. We've got columns on the top and we've got rows on the bottom. So when we're subsetting, we have to pick both the column and the row, or sorry, I should say this differently. We have to pick the row and the column. It's always row column is the order that you always use in mathematics and other things as well. It's just the standard. So we pick based on the row, and then we're also going to pick based on a column index as well. So we're going to pick two different kind of indices now. We got a row index and a column index that we have to pick. Whereas in a vector, we don't have to worry about that. We just have kind of one kind of column of data. So we only have one number going in. But now if we're subsetting a data frame, so human age is not a data frame. We can't do that on this. But if we use our cats data frame, cats 3, for instance, we can write something like 1, 1. This will give us the first row and the first column value. So in this case, it gives us just the value of calico, and I think I've left it as a factor. So we've got the levels printed at the bottom, but just ignore the levels, just gives you the total number of levels if it's a factor. So this just gives us the first row, first column value of a data frame. And again, if we just look at what cats 3 is without any subsetting, we can just look at it by itself. Yeah, so what it's given us is this first row and first column. So where those two intersect, that's just the calico value. We could do it again with something like, if we wanted to get out tabby, for instance, what would be how would we subset out tabby, the value of tabby by itself? Any ideas? We'd start off with this square brackets. We have row and we have column values. So if we wanted tabby, for instance, what's the row number for that row which tabby's in? It would be this row, right? The third row. So that's the first thing we put. It's always row by column. So we put 3 first. So we got 3 for our row. Now what about the column index? It's going to be it's in this first column, right? So first column, second column, third column, fourth column. So if we wanted it, we're now going to pick 3 and then the first column. So 3 and 1. And you don't have to worry about spaces or anything in this. It doesn't matter if there's spaces. I could add in a bunch of spaces and it still will work fine. So you can see when we do cats 3, 1, we're getting the third row and then the first column, which gives us the value of tabby in this case. Oh, sorry, it's cats 3 again. I keep changing. Cats 3, sorry, which is tabby, and it's got this levels again because right now it's a factor. So if you see this levels part, it just means it's a factor. Is everyone cool with that? So another thing we can do, you might be wondering, what if I just want to subset by a certain column? Or what if I just want to subset by a certain row? And I don't care about the other one. So maybe you don't care about one of them, but you care about, columns or rows, but not both of them together. Because right now we're doing both together. Well, we can do the same thing. If we, for instance, just wanted column 2, which is the weights, we would write open the square brackets. And I always start off with just putting in spaces by itself. And if we just wanted column 2, this is the part where we designate column, the second value. So it's column 2 would just be a 2 here. So this gets us just column 2, but all rows. Row index is left blank. So if we leave it blank, that means we want all the rows. So we can put a space there, or we don't even have to put anything. And what this is going to do now is it gives us the values of all the weights. So again, if we just look at the original data set, what it's done is it's given us, here we've got all the weights out, and here you can see in the weight column, it's the exact same weights. We've just picked out a certain value of it. All right? So far, so good. So now what if I said I want the values for cat number 3? I want all the data from cat number 3. How would you subset the data set to get that? Any idea? We can make this challenge. So how would we subset the data so we just get values based on cat number 3, all the data we have on cat number 3? Any idea? Yeah, perfect. So we cat's 3, and then we start off with our row and column indices. Again, just to be extra clear, I like to just, if I know it's a data frame, I can write this and it should work by itself. That means, because if we leave blanks, we can get everything. So I always start off just by writing the structure of it, and then I fill in what I actually want to subset. So if we want, in this case, cat number 3, which happens to be the 3rd row of data, as Katie was saying, we write cats 3. The one thing that I think might screw it up is the double question marks. That might not work. Just kidding. Don't run that. No, yeah, you're absolutely right, Katie. So it's just cats 3 like this, no question marks in there. If you wrote question marks in, you might see a plus sign. You'll just have to click on your console and hit escape because it might be expecting inputs. But cats 3 by itself is exactly right. It's giving us the 3rd line of basically the data set. So we're just getting out that important row of just the tabby cats, which is what we wanted to do. So this is exactly right. This can be useful, for instance, if we're just trying to subset a certain values from our data set. Maybe we have an outlier that we're trying to find, and we can look in our data set and find, oh, it's the 25th row. Let's just get the 25th row of data. And so we can just, then we'd write 25 in here. But a problem is if I write 25 in here, it doesn't know what the heck I'm talking about because there's only four rows of data in this case. So we have to be conscious of how many rows there are in this data. So here we're just trying to get the 3rd cat. But if you go outside of it, it might give you a bunch of NAs. It might even give you an error in some cases. So that's subsetting data frames for the most part. But we also have these other operations like we did above. So remember, when we subset a vector, we could also use this minus stuff. We could use this 1 to 3 kind of thing. And I'll show you another trick. We can also pick certain values out that we want from certain things. So for instance, if another thing we could do is we can get the, let's make it challenging, the first and 4th rows from cats 3, as well as the 2nd and 4th columns of cats of the same data set. So we want the 1st and 4th rows from cats 3 as well as the 2nd and 4th columns. It's a great practice to try this yourself. It's going to be tricky though, because there's one thing that I haven't taught you yet that you can do. So we can write something like cats 3, and we'll start it off with rows and columns again. We'll just leave it blank at first. And the way to approach this, you know, what you might be inclined to do right away is you might be like, okay, we need 1 and 4 for the rows. So I'd write 1, comma 4. That will work, right? And we can just try that without any column subsetting yet. And if we do that, somehow it works, but it shouldn't be working. It's not giving us what exactly we want. See, it's like, it's giving us 2 as the answer, but we wanted 2 rows. That doesn't really make sense just to give a value of 2 out. So the problem is that R is confused because it just wants kind of 2 numbers going in. If you give it, here we've kind of given it almost 3 numbers. We give it 1, 4, and then a blank row, which is kind of like everything value. So what it does is it just kind of ignores this. It essentially R is deleting this in R's mind, and it's like, hey, they want 1 and 4, which is a value of 2. So it's actually not giving us the first and fourth rows. It's giving us just the first row and the fourth column when we write this. So it's not working quite how we want it. So the trick to get through this, and this is something that I use all the time, is you can just write a vector instead. So instead of writing 1 and 4, I'll just put in a vector. And the way we put in a vector again is we write this C command. And we can now put in any numbers we want. So if we want 1 and 4, we write C, 1 and 4. And it kind of packages them together and then passes it to the subset all as 1. So then it works properly if we do that. So now if we run this, it gives us rows 1 and 4. So so far so good. Now, how about you guys try and add in, now we just want a subset as well for the second and fourth columns. So we just want the weight and the age of those 2 columns. Can anyone add this to the code that we already have? How would we add this to the code to make it also get just the second and fourth columns? Yeah. So that got it right. So that should be that's one way to do it for sure. Did anyone else try that? So we just write C, 2 and 4, and that does not do it. No, sorry, that's wrong. C, 2 and 4 by itself does not work. No. No, that's a good hint though. So if we want the second and fourth columns, right now what we've got, yeah, exactly. So we've got these, right now we're subsetting, if you imagine, as we had it before, this is the row index, this is the column index. The first thing we do is we fill in the row index. That was this part where I'm adding spaces so it's really clear. This is our row index. We just want the first and the fourth row. And then the column index is where we put the second and the fourth column. So we put C, 2, and 4. So this is where we get first and fourth rows, second and fourth columns. And now when we get this out, we can print this out, and we're just getting weight and age for the first and the fourth rows, which is exactly kind of what we're asking for. So now we've got a really complicated subsetting action that we've got going on, but you can see how easily it's done like this. We can also do things like, similarly, if we just did the exact same thing, but we wanted the opposite of it, we could, instead of rewriting it as 2 and 3 and 1 and 3, we could write minus C, 1, 4, comma, minus C, 2, 4. And in this way, we don't have to worry about rewriting it all. I'll just space it out so it's a little bit more clear what I mean. So here we're getting the first and fourth rows. Here we're getting the opposite. Get the opposite of what we had before. So when we run this, we'll see that it's actually the exact opposite. We're getting the second and third rows because we're doing minus 2 and we're basically dropping rows 1 and 4, and then we're dropping the second and the fourth column as well. So we're just getting in that case, we're just getting the first and the third column now when we're subsetting. So this minus can also work with vectors. If we just put it like this, we're getting minus. Yeah, and you can also give it, yeah, you're exactly right. We can also give it a range. We can, for instance, delete this and wait, let's say we just want rows 2 to 4. We can run this now, and this should work. But one thing that you can't do, and this is another thing that we can't do. Watch out for ranges that go over 0. So if we add a minus to this, let's say we didn't want rows 2 to 4, so we go minus 2 to 4. We try and run this, and it actually gives us an error. And the reason why it's giving us an error is because we're trying to subset over 0. So if we look closer at this, if we just run this part together, just run this minus 2 to 4, it gives us values from -2, -1, 0, 1, 2, 3, 4. And you can't subset a value of 0 in R. There's no such thing as a subset of 0. Like I think if I try and do this, I don't think it'll work. Yeah, data frame, so it just doesn't give us anything out. So it gets confused when you try and go with these minus numbers. So if we wanted to do a minus over a series like this, we'd go minus and we'd have to put in a vector, something like this. So now we're just getting -2, 3, 4. Instead of -2, -1, 0, 1, 2, 3, 4, which confuses the heck out of R. So now we can do a minus on a series. So you can absolutely, so I was just talking about Laura's question. You can do a series where we go 2 to 4 or 1 to 3 or anything like that. But the important thing is just try and print it out what you're putting into each index before you try and run it. So you can print out like, okay, if I'm doing -1, 4, what does that look like? It's giving me a value of -1 and -4 together. If I go 2 to 4, what is that doing? It's giving me 2, 3, 4 together. And if I'm trying to get -2, -3, -4, which means exclude 2, exclude 3, exclude 4, we got to write it like this in a vector. And we can also do a very complicated. You're getting ahead of me. Yes, we can do a more complicated ways of subsetting. So I think I'm almost out of time. But one thing that commonly we're asked to do is we want to subset for the maximum of some value. So let's say we got an outlier in terms of age, for instance. So let's retrieve the cat with the maximum age. But I want you to imagine for a sec that we don't just have 4 rows, we have like hundreds of rows, and we're really lazy. We don't want to look through the data, so we just want R to do it for us. And so we want to use subsetting commands to get the maximum age of cats without actually looking at the data set. So one thing we can do to get that is we can write cats3, we're going to subset for some index. And let's say we just want to retrieve the full row for whatever cat has the maximum age. So in this case, we're going to leave the columns blank. We want all the columns. We want to get all the columns up. So that column part, we're going to leave blank. And we want to get some idea of the cat with the maximum age. So we can start this out by just basically retrieving cats3 $age. We want the cats3 $age where it's the maximum. So we want this value where it's equal to the maximum of cats3 $age. So in this, it's a bit confusing how I've written this. Let me just explain it. When this first part, we're asking for the maximum of all the cats with certain ages. So if we do the maximum of this column, it gives us a cat of age 9. In the next part, we're saying, okay, now I want to look at all the cats' ages, which currently there's 4 different values, and I want to say which one has the maximum age. So I'm saying which cat's age is double equal to the max cat age, and this gives me a vector of true or falses. So now remember, true or falses are kind of like 1s and 0s. So we're kind of subsetting in a different way now. We're saying every time it's false, we're going to essentially ignore those ones, and every time it's true, we're going to pull out those ones. So in this part, we're saying, okay, the first cat, is its age the maximum age? No. Second cat, max age? No. Third cat, maximum age? No. Fourth cat, maximum age? Yeah. So it's now going to pull out that 4th value. And finally, when we run this all together, when we subset this all together, we get out the row with the maximum age. So this is how you can subset for like the max value. If you want to do the minimum value, we just change this max to a min, M-I-N, and we can get the row with the minimum value. And this is the way I always find my outliers. So if you have some column you're looking into, like it could be age, it could be whatever you're studying, you can look at max and mins like this and quickly find which data point was it that has the minimum age, which data point had the maximum age, and you can quickly pull it out this way. And I think I'm out of time with that. So thanks for listening so far. Does anyone have any questions that are easily answerable within a few minutes. And thanks for sticking around past the time. I hope it was clear. I'm sorry to rush. There's a lot more in the data problems that you can go through. But stick around. Don't leave yet because there's a draw coming. You don't want to miss the draw. That's why you're all here, right?
Thanks, Kevin. That was awesome. It's you've become very adept at giving these talks, I think.
Oh yeah, so I should have mentioned I used to do this for QCIF, teaching a bunch of people, like 30 people in a room all together, and everyone was always very confused. So I'm used to adapting slowly to how much time I have. But.
Awesome. Yeah, thanks a lot for doing that. If there are no questions, I can do the draw. How do I do this?
In the meantime, while I was figuring that out, remember next week is Saul's talk on NMDS, if you feel like attending. So next Monday, talk on NMDS by Saul.
What does that mean?
Non-metric multidimensional scale.
Okay, cool.
It's
Excited to learn then.
Do you want to? Are you on a mic? Can you explain, or I know Cesar does it too.
All right. Can you see my screen? I have the list of people. If you're not in the list, it's because you have already won one, I guess. So let's run the pick a winner function. All right, picking a winner. Beep, bop, boop. It's doing its calculations. Drum roll, please. The winner is. The winner is Abdul. Yay. All right. So congratulations. You can contact me or Ira. I have blue cups and Ira has green cups.